Question 23. The figure shows a regular tetrahedron. Which of the following are true? 1. It has a total of 7 axes of rotational symmetry. 2. It has a total of 4 axes of rotational symmetry with order of 4. 3. It has in total 3 planes of reflection. Okay, so we'll check 1 and 2 together since they are both about rotational symmetries. The first kind of rotational symmetry would be passing through the edge and then coming out from a face opposite of the vertex of the tetrahedron. Okay, how many this kind of rotational symmetry are there in a tetrahedron? The answer is 4, because there are 4 vertexes in a tetrahedron and a total of 4 faces in a tetrahedron. So the total number of this kind of axis of rotational symmetry is 4. So we write down 4 here. Okay, what is the order of this kind of rotational symmetry? Do remember that this is a tetrahedron, so the base shape is a triangle. Therefore, the rotational symmetry should be with an order of 3 only instead of 4. Okay, so we have 0 axis of rotational symmetry with an order of 4 up till now. The second kind of axis of rotational symmetry actually pass through an edge and comes out from another edge. So this kind of axis of rotational symmetry will actually pass through 2 edges of the tetrahedron. And how many edges are there in a tetrahedron? There are 6. So there are 3 pairs of this kind of axis of rotational symmetry. And what is the order of this kind of rotational symmetry? Is actually 2, but even if you don't know it, it doesn't matter because you only have 3 of this kind of rotational symmetry, and the number of rotational symmetry with an order of 4 required in option 2 is 4. So you still have, no matter what, you will not have 4. So 2 must be incorrect. And 1, we get 4 plus 3 axis of rotational symmetries, so 1 is correct. How about 3? There are in total 3 planes of reflection. So the first kind of planes of reflection, we can cut the tetrahedron like this, and we can cut it like this, and last but not least, like this. So up till now, all of the planes of reflection is actually cutting from, maybe we have a knife here. It's actually cutting the tetrahedron from the top. They all converge to the top. And we have 3 now, but there are more. We also have some planes of reflections like this. And maybe I will use another color like this, and last but not least, like this. So we have 3 more planes of reflection that are not splitting it from the top of the tetrahedron. So 3 is wrong. The total number is 6. So only 1 is correct. Answer A.